In this lesson, we are focusing on special right triangles, specifically 30, 60, 90 right triangles. Before we get into those special right triangles, we have a few review topics that we're going to go over. First is simplifying square roots. So we talked about this in the 45, 45, 90 video. However, we're also going to mention it here because it also applies to these special right triangles. So anytime you have just a radical with that number inside, we want to simplify that radical as much as possible, and we do that by splitting it up into two factors. So we can split a radical into two factors, and our goal is to have one of those factors as a perfect square. So for example, I could do 15 times 3 to get to 45. However, 15 is not a perfect square, meaning there's nothing times itself that gives me 15. Same with 3. 3 is not a perfect square because nothing times itself is going to give me 3. However, if I break it up to 9 times 5, 9 is a perfect square because 3 times 3 is 9. So what we get is we have the square root of 9 times the square root of 5, where the square root of 9 becomes the whole number 3. Now we have completely simplified the square root of 45 into the whole number 3 times the square root of 5. Now we know we're done because the square root of 5 doesn't break down anymore, it's just 5 times itself, 5 times 1. So 5 times 1 is the only way we can get 5, that's how we know we're done. Along with that is rationalizing the denominator. When we are solving problems using special right triangles, sometimes we'll run into a situation where we have an equation that looks something like this. 3 equals x times the square root of 2. Well, our goal here is to solve for x. So to do that, we need to get rid of the square root of 2. Since these are being multiplied, we'll have to do the opposite of that on each side. So we would divide by the square root of 2 on each side of that equation. The square root of 2 divided by the square root of 2 is 1, so that leaves us with just 3 over the square root of 2 equals x. Now, this is technically a correct answer. However, we don't want to leave a square root in the bottom of a fraction. We don't want to do that because the square root of 2 is not rational. It's not a whole number. So to prevent having an irrational number in the denominator, we have to rationalize it, which means we have to get rid of that radical. So to do that, we're going to multiply the top and the bottom of that fraction by that radical, which is the square root of 2. So the top and the bottom gets multiplied by the square root of 2, and we multiply straight across. So 3 times the square root of 2 and the square root of 2 times the square root of 2. The top part, 3 square root of 2, stays exactly how you see it. Then the bottom, that should eventually simplify to a whole number. That's the whole point of doing this. So when we multiply 2 times the square root of 2, the square root of 2 times the square root of 2, we are going to multiply within the radical. So we're going to multiply 2 times 2, and that gives us the square root of 4. Now the square root of 4 is a whole number. It's equal to 2. So we just simplify that and we're done. Now we have a fraction, but there is no radical in the denominator. We have rationalized it. The final review topic that we need to know for 30, 60, 90s is the Pythagorean theorem. The Pythagorean theorem states that for any right triangle, so in this case we have a right triangle denoted by that little box in the corner, and we have our legs A, B, and the hypotenuse C. For any right triangle, A squared plus B squared is equal to C squared. Now let's discover what is that special ratio between 30, 60, 90 triangles. What is the relationship between the legs of a 30, 60, 90 right triangle? We're going to have to use a combination of trigonometry and a combination of Pythagorean theorem to solve for all three of these sides. We're just given one side, but we know both of the angle measures, and we know how to solve for missing sides of triangles using SOHCAHTOA. So what we could do first is we could say, based on this 60-degree angle, I have the adjacent side, and let's say we want to know the hypotenuse, because that's directly across from the 90-degree angle. If we wanted to know the hypotenuse, we could use SOHCAHTOA and find that length. So if I have the adjacent and hypotenuse are the sides that we're looking for, and we have that 60-degree angle, we would set up, based on SOHCAHTOA, if I have the adjacent and the hypotenuse, I would need to use cosine. So the cosine of that 60-degree angle is going to be equal to the adjacent over the hypotenuse. The adjacent side is 2, and the hypotenuse, we don't know. We're going to call it x. Well, we need to solve for x, so going back to what we did when we were solving with trigonometric ratios, we're still just going to use the same process to get x by itself. So to start with, we're going to multiply by x on both sides to get it out of that denominator. So that way it eliminates on the right side, and we're left with x times the cosine of 60 degrees equals 2. Now we still want to get x by itself, so we need to move the cosine of 60 by dividing it on both sides. So we're going to divide by cosine 60 on each side. So cosine 60 over cosine 60 is 1, so they cancel. And our final solution is x equals 2 over the cosine of 60. Well, let's see what that is equal to. I'm going to make sure that I'm in degree mode, and I am, so that's good. 2 divided by the cosine of 60 degrees is equal to 4. So our hypotenuse then is 4. Okay, so now I'm going to erase what I've drawn on top of this triangle, and we're going to look at what we have now. So we know that we have one leg that's 2, we have the hypotenuse that's 4, so the simplest way to get to side B would be to just use the Pythagorean theorem. You could use trig again, you could use a trig ratio. However, we are talking about the most accurate forms. Instead of rounding decimal numbers, we're going to try to use some radicals instead. So if I have a squared plus b squared equals c squared, that's going to be a squared plus b squared equals c squared. And I'm going to plug in 2 for a. We don't know b, so we're going to leave that as b squared, but we do know that c is 4. Now, if I simplify, 4 plus b squared equals 16. And we're trying to get b by itself here, right? Because we're trying to solve for b. So we're going to have to subtract 4 on both sides. So that would be b squared equals 12. Then, if I am solving for b, I still need to take that square root to get b completely by itself. So we have b equals the square root of 12. Well, again, that's perfectly fine. That is accurate. However, we want to simplify it if we can. So if I break this up to be 6 times 2, neither one of those are perfect squares. 12 times 1 is also not a perfect square. But 4 times 3, 4 is a perfect square. So that's the perfect square that I'm going to use when I factor. because the square root of 4 simplifies to be 2. So b is 2 square root 3. I know that seems like a lot of work, and you could continue to do that. However, after we do the next problem this way, we may start to see a pattern so that we don't have to do all of this work every time we see a 30, 60, 90 triangle. So as we complete the next problem, look at these sides and keep in mind some pattern that we may see moving into the next problem. All right, let's start with finding the hypotenuse. So again, the hypotenuse is directly across from the 90-degree angle. And I'm going to use this 60 again because that's what we did last time. So I'm just using the same process. And we have that adjacent side, which is 5. So what we're going to do here is use trig. Again, because we have adjacent and hypotenuse, we're going to have to use cosine of 60 degrees equals, this time it's 5 over x. Again, just getting x by itself, we're going to do times x on each side. That means they cross out on the right, and we have x times cosine 60 equals 5. Getting x by itself, we need to divide by cosine 60 on each side of that equation. And that eliminates the cosine 60s on the left-hand side of the equation. So now that gives us x equals 5 over cosine 60. And let's see what that's equal to. So 5 divided by cosine 60 degrees, that's equal to 10. So our hypotenuse then is a length of 10. Now we just need to find that third side, b. So if I'm going to use the Pythagorean theorem, that's going to be a little bit quicker. And it's going to help us get an accurate length because we're going to be using radicals instead of decimal numbers. So again, a squared plus b squared equals c squared. A is 5. We don't know b. And c is 10. So that's going to be 25 plus b squared equals 100. I'm going to subtract 25, so b squared equals 75. And we need to take the square root on each side to get b by itself. So we have b equals the square root of 75. Again, we want to simplify this if we can. So what numbers multiply to be 75? Right off the top of my head, I'm thinking 25 times 3. Typically, if I have 25s, 50s, or 75s, I'm thinking about change for $1 usually. So that's just one place to start. So if I use 25 times 3, that actually will work because 25 is a perfect square. So the square root of 25 is 5. So b is 5 square root of 3. Right, now to give us kind of a clear picture, I'm going to erase what I drew on top of my triangle. I want us to look at both of those triangles. Okay, so just look at this one. Look at the sides. The short side was 2, the hypotenuse was 4, and the long side was 2 square root of 3. Now compare that to a short side of 5, a long side of 10, a short side of 5, the hypotenuse is 10, and the longer side is 5 square root of 3. So let's see, is there some relationship between those three numbers? Is there some relationship over here between those three numbers? So I want you to think about from 2 to 4, in the direction that we went anyway, from 2 to 4, what's that relationship that would be the same as from 5 to 10? So from 2 to 4, what happened there? From 5 to 10, What happened there? What's that relationship? And then take that same leg, 2, and go to 2 square root of 3. What's that relationship? How is it similar to 5 going to 5 square root of 3? That's what we're going to explore in the next piece. So coming up with the rule really comes from just the process of using trig and the Pythagorean theorem to find those missing sides. So you'll find with any 30, 60, 90 triangle, we have what's called the short leg, that's the shorter leg, the long leg, and you have the hypotenuse. We always reference the short leg when we're talking about the relationship between the legs for 30, 60, 90s. So this is your main leg that you need to know. The short leg is very important. So from the short leg to the hypotenuse, we multiplied by 2. And from the short leg to the long leg, we multiplied by the square root of 3. Right? Because we went from 2 times 2 to get 4, and 2 times the square root of 3 gives us 2 square root of 3. Now let's compare that to the other one that we did. 5 being our short leg, from 5 to 10, we multiplied by 2 to get the hypotenuse. From the short leg 5 to the long leg, we had to multiply by the square root of 3. 5 times the square root of 3 was the long leg. So you're going to see that for any 30, 60, 90 triangle, the short leg is kind of like your base number that you need to know. The hypotenuse is always 2 times the short leg. Let me move this over a little. Hypotenuse equals 2 times the short leg. And the long leg is the short leg times the square root of 3. And that's the relationship between them. Based on your short leg, the hypotenuse is double that, and the long leg is the short leg times square root of 3. Now let's do some examples. We want to make sure that we keep these in simplest radical form. So this time we are not given the short leg. So we kind of have to work backwards, right? Because we know that if this is the short leg, this is the long leg, and this is the hypotenuse, we know that the long leg is equal to the short leg times the square root of 3. So what we know is that 6 is our long leg, so that's equal to the short leg times the square root of 3. Now here is kind of like what we did with 45, 45, 90s, where we just have to get x by itself and make sure that there's no radical in the denominator. So we're going to have to divide by the square root of 3, and then multiply by the square root of 3 on the top and the bottom. Now simplifying that, we would get 6 square root of 3 over the square root of 9 equals x. All right, so I'm just going to recap that because it may have been a minute since you have done a problem like this. So we started by knowing the long leg is 6, and we know that the long leg is always equal to the short leg, so x is representing the short leg, times the square root of 3. So we know that 6 equals x times the square root of 3. We had to get x by itself, so to do that we had to divide by the square root of 3 on each side. That eliminates them on one side, and we're left with just 6 6 over the square root of 3 equals x. Then we have to do times square root of 3 times square root 3. So that's where we are here. Now we multiply straight across. So 6 times square root of 3, and then the square root of 3 times the square root of 3 becomes the square root of 9. Now this puts us in a really good position because the square root of 9 is a whole number. I'm going to move this just a little bit so that it may be a little easier for you to follow if I stack it like I did last time. So there we go. All right, so 6 square root of 3 over 3 equals x. Now technically this is correct. However, we have 6 over 3, which does simplify. So that's actually 2 square root of 3 equals x. So the short leg is 2 times the square root of 3. All right, now let's try another one. This one we're trying to find the short leg if we are given the hypotenuse. The hypotenuse is always 2 times the short leg. This time the short leg is x, so we know the square root of 8 is going to be 2 times x. This one's going to be really easy because we aren't dividing by a radical. So to get x by itself, I just need to divide by 2. So that gives me the square root of 8 over 2 equals x. Now the only thing we want to do here is see if we can simplify the square root of 8. And we can, because the square root of 8 is the same as square root 4 times square root 2. All right, so the square root of 4 is 2. So that leaves us with 2 square root 2 over 2 equals x. And now 2 over 2 equals 1. So we end up with just a really fun answer. X just equals the square root of 2. Or, if you wrote it that way, square root of 2 equals x. Because this equals 1. So the short leg is just the square root of 2. Another way that we could approach this one is we could look at the square root of 8, and we can say the square root of 8, we can go ahead and break that down to be square root 4, square root 2. Well, if we break that down, that gives us 2 square root 2. And we know that the hypotenuse is 2 times the short leg, so 2 times the short leg. So this would have to be our short leg, square root of 2. That's another way you could go about it if your hypotenuse isn't completely simplified. Or you could continue to just use the setup of the ratio that the hypotenuse is 2 times the short leg always. Okay, now we have a 30, 60, 90, and we need to find the hypotenuse given the long leg. So we have the long leg, and we need to find the hypotenuse. Well, we know the hypotenuse is always 2 times the short leg, and we know that the long leg is the short leg times the square root of 3. So what we would do here is I would work backwards and find the short leg first, because once I know the short leg, then I can just do 2 times that and I have the hypotenuse. So let's work to find the short leg. I'm going to call the short leg y. So the long leg, 4, equals the short leg times the square root of 3. I have to divide by the square root of 3 on each side, and we have to do that fun process of finding the rational version of this. So square root of 3 over square root of 3 cancels, and that leaves us with, I'm going to move this over again so that we have some space to see. right, so now we have 4 over square root 3 equals y, and we need to multiply by square root 3 on top and bottom. And multiply straight across. So that gives us 4 square root 3 on top and square root 9 on the bottom. The square root of 9 is just 3. So that leaves us with our final answer for the short leg, 4 root 3 over 3. Now, make sure that you don't cancel these out because you can only do that with the whole numbers. All right, so if the short leg is all of this stuff, then the hypotenuse is going to be 2 times that. So x is going to be 2 times the short leg, which was 4 root 3 over 3. So we're just going to multiply that 2 times 4, and that's pretty much it. Let's see, so 2 times 4, that's going to be 8 square root 3 over 3. Okay, number 4. Find the hypotenuse given the short leg. Oh, this one's super easy. Thank goodness, right? Because the hypotenuse is just 2 times the short leg. So we know the short leg is 5, so we know x is just going to be 2 times 5, which is 10. And hallelujah, we're done. That's it. Super easy when you have the short leg. Number 5 is also not so bad because we have the short leg, which is our magic leg. So the short leg compared to the long leg, the long is always the short times the square root of 3. So x in this case is just going to be 2 times the square root of 3. And that's it. All right, and now find the long leg given the hypotenuse. This is kind of backwards from the last one we did. So given the hypotenuse, what we know is that the hypotenuse is 2 times the short leg. So I would work backwards. I would start at the square root of 8 and then find the short leg. I'm going to call that y again. So we know the hypotenuse, which is the square root of 8, is equal to 2 times the short leg. So again, pretty easy because we just have to divide by 2 and we're good. The only thing we have to make sure of is that we simplify the square root of 8. So remember the square root of 8. I'm going to write that out on both places so that we can reference it. The square root of 8 simplifies to be square root 4 times square root 2. So far I've crossed out those 2's and I've just changed the square root of 8 to be root 4 root 2. Now I can simplify the square root of 4 is just 2 root 2 over 2 equals y. So many 2's. Now 2 over 2 is just 1, so they cancel. And we have that y is just equal to the square root of 2. Okay, so you can go back, like I said earlier, and go ahead and simplify the square root of 8. We ended up getting that the square root of 8 after we broke it up ends up being just 2 times the square root of 2. So by breaking this up and simplifying it, we already have the hypotenuse equals 2 times the short leg, where the short leg is what we were looking for. Okay, so our short leg is the square root of 2, and now we want to know the long leg. Well, we know that long is short times square root of 3. So x is the short leg, square root 2, times the square root of 3. So when I multiply those together, I get the square root of 6. And I can't simplify that anymore, so that's it. It's just the square root of 6. That was kind of a lot, but again, combining what you know about the Pythagorean theorem in conjunction with what you know about radicals, in conjunction with what you know about just solving equations in general, is really just a process of solving equations. It just so happens that you're given a different piece of the equation every time. So that's pretty much it. For 30, 60, 90 right triangles, this is the most important thing to remember. However, if you forget, you can always get back to that by using just your regular trig ratios and the Pythagorean theorem.